Hello again, guys. Welcome back for 12.2, dealing with triangle congruence by SSS and SAS. This stands for side, 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 or side, angle, side. Notice the angle is between the two sides. So if you looked at the solve it in the lesson, please make sure that you have the lesson up at the same time as you're working through this. You notice that in the solve it, we dealt with two triangles being congruent, and therefore they have three pairs of congruent angles and three pairs of congruent sides. If we know all of this, then we can prove the triangles are congruent. Likewise, if we know the triangles are congruent, we know all of this. But these 6 pieces of information are more than what we need to know. So, check this out. Essentially, we can prove that a triangle is congruent if we have all corresponding parts are congruent, or we can just use 3 sides or 2 sides and 1 included angle. The first part of what we just said, the using 3 sides, that is this right here, the side-side-side postulate. So what we see is that if we have 3 corresponding sets of sides that are all congruent to each other, then we know the triangles must be the same size. You should remember from your triangle construction unit that if you are given 3 lengths, say a given length 1, a given length 2, and a given length 3, you only have one option of triangle that you can form. It might be able to look different, be turned, rotated, flipped, whatever, but it's going to be the same triangle. Likewise, if another triangle has the identical lengths for its legs, it has to be congruent, has to be the same type of triangle. Now, why do we call this a postulate and not a theorem? Take a second to read what a postulate is. I love this phrase right here, an accepted statement of fact. It just sounds so powerful. So as long as we know all 3 sides have congruent sides on another triangle, then we know they are congruent. Moving on, we have the got it from part 1, so please process through the first part of the lesson and then come back here for the got it. Once you're back here on the got it, take a second to try this on your own. Try to write a proof. Really, to prove this, you can just show out that you have, and we want to prove it using side, 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 so you can show that we have 3 sets of congruent sides that then would be in the correct order to prove this triangle pair is congruent. If you've not solved this yet, please take a second to pause the video and do so. I've highlighted here my BC congruent to BF, then CD to FD, and the other thing that I see is I have a shared side right down the middle of BD. So my proof, just written out an explanation, can be that my 2 pairs of sides are given as congruent, and then by the reflexive property, BD is equal to BD. Therefore, I have 3 sides, letting me prove this congruent by the side, 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 or SSS congruence postulate. Now, oftentimes we won't know all 3 sides. That just is too nice and easy for us. So a lot of times we'll end up knowing 2 sides and possibly one of the angles. So read through this, make sure it makes sense, pause the video for a second. So what we're talking about here that is really important is the included word. An included angle is one that falls between 2 sides that you already know about. So here we go, color coded for you. Angle A here is included between BA and CA, or AC if you say it the other way around. And then line or side BC is included between angle B and angle C. So you can have an included side or an included angle. Now what we're going to be discussing here in this lesson is all included angles. So when we look at postulate 15 down here, we have the side angle side. So this is actually one of my favorites. So if 2 sides and an included angle are congruent to 2 sides and an included angle of another triangle, that then means that these 2 triangles must be congruent. Now you may have actually applied this side angle side property in the real world without ever noticing it. So say we had a box that we're trying to fit through a doorway here. If you want to know, will this box fit through the doorway, should it go this way or should it go the other way, you might use your arms to span the distance and then turn and check that distance. But if you change the angle between your arms, that won't work. So you keep the angle fixed, and then the distance between your arms, well, you can't change the length of your arms, so those sides will stay the same. As long as you keep this angle fixed when you turn, then that distance will be the same distance that it was over here. So you can go ahead and read through the rest of that if you would like. Please make sure you've worked through section 2 of the lesson to make it to our got it here. We're trying to prove that triangle LEB would be congruent to triangle BNL. Now the issue here is, what else do we need? We don't have everything that we need, so what other information is needed to prove from side, angle, side? Well, we do have one angle here, angle L, congruent to angle B. And then if I look at LEB compared to BNL, I'm going to pause and color code this. So these are my two triangles, and they already share this common side LB right here. So we already have a side that's congruent, and we already have an angle pair that is congruent. The only thing that we would need left to prove side, angle, side is the other sides to make that angle our included angle. So I could use side LE in my green triangle, and I could use side NB in my blue triangle, and if I can prove that NB is congruent to LE, then I can prove they're congruent. So there you have it. For a little bit more practice, come down here and check out problems 3 and 4. Pause the video and go ahead and notate what else we would need, if we need anything else, to prove these two triangles congruent, and then to prove these two triangles congruent. So again, we already have one set of congruent sides given to us, one pair of congruent angles given to us. So we would need the sides that make that angle included. So we would need to prove LG congruent to MN. If you haven't done so yet, try number 4. All right, so in number 4, we actually have an option here. So your answer could be either of these. We could either prove side, angle, side by proving the other sides congruent. So that would be sides RS and UW, because again, we would have to make this congruent angle that we know included, and we already know that VW is congruent to RT, so we could do those sides. Or, I'm going to change my color coding here, because we already have two pairs of congruent sides, we have RT congruent to VW and TS congruent to UV, we could just make the included angle between them congruent, and if we knew that angle T was congruent to angle V, then we would easily be able to show from side, angle, side that these triangles are congruent. Take a moment then, assuming that you've worked through part 3 in the lesson, to check out the problem 3 got it, whether we would use side, 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 or side, angle, side here. Now what you'll notice is we have 3 congruent sides given to us and congruent angles, so a quick immediate thought would be I can use either, but pay attention to the details and really analyze what would be best. So notice here in my first triangle that I have my included angle between my 2 dashes and my 3 dashes, or what I've color-coded blue and yellow. And over here, my included angle is between my 2 dashes and my 1 dash. So this cannot actually prove side, angle, side congruence. So we would instead have to choose the side, side, side congruence to prove these triangles congruent. If you would like the nice written out response to that, that is why. And with that, that is all I really have for our 12-2 lesson on proving triangles congruent. So please make sure you've worked through all the Pearson, do your practice work, and let me know if you have any issues. Thank you very much and have a wonderful day.